Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to another lecture of basic electrical circuits. In the previous lecture we were looking at two-port networks and we considered Y parameters in detail. Y parameters are where you think of voltages as being applied or voltages as independent variables and the currents into the two ports as dependent variables. Okay. Now, when you write the currents as a function of voltages, a linear combination of voltages, you have these proportionality constants which are Y parameters. Now, we can also have currents as independent variables and voltages as dependent variables and so on. Okay, so we will discuss those parameters today. Okay, I believe now we are set to go. So we have two ports. That is two terminal pairs where we can apply voltages and currents. Okay. So previously we wrote the currents as a function of currents as functions of voltages. Now this is not the only way to do it. We can also write the voltages as functions of currents. If we do that, we get expressions of this type where V1 and V2 are linear combinations of I1 and I2. Okay. Now, clearly, these constants which give you voltage from current, they have dimensions of resistance or units of ohms. Okay. Now, this set of parameters is known as Z parameters. Okay. Now, what this means is we think of a picture like this: I1, I2, that is current supplied to the two ports, and we are measuring the two voltages that appear as a result. Okay. Now, the same thing can be written in matrix form. Okay, times I1 and I2. So, are there any questions about the definitions of Z parameters? Any questions about the two port Z parameters? The use of Z parameters is similar to the use of other parameters. When you have a two port, that is, when you have a circuit with some input and some output, you can treat those two as two ports. You have a complicated circuit inside. You don't want to worry about the details of the circuit. You just want to describe the relationship between the input voltage and current and the output voltage and current. Okay. This can be done in many ways, and Z parameters are one of the ways of doing that. Okay. Yeah, in this case, all Z values are resistances or impedances. Okay. We have been talking only about resistive circuits, so they are real numbers and there will be resistances. Okay. So now we interpreted the Y parameters as short circuit parameters. This we discussed in quite some detail in the previous lecture. That is, to measure Y parameters, you have to short one port and measure the apply voltage and measure the current at one port or the other port. Okay. So those are Y parameters or short circuit parameters. Now there is a question, which is better, Y parameters or Z parameters? There is no such thing as better. Okay. This is a matter of convenience, right? Sometimes you calculate using conductances, sometimes you calculate using resistances. Now, which is better depends on the context. It's more a question of convenience. So, Y parameters and Z parameters are equivalent descriptions of the same network. Now, sometimes some are easier to use, and we will later see some of them may not exist for certain types of circuits. Okay, and only some of them will exist. Okay. So now, please tell me, just like in Y parameters, we short circuited one port in order to measure the Y parameters. Okay. So in this case, I have So now my two port picture is over here. So let's say I want to measure Z11 and Z21. Okay. Please let me know what you will do. Let's say you were given these two port in the lab and you were asked to measure it in any way. Uh, Please let me know what you will do to measure Z11 and Z21. Okay. I think this question is repeated. I already answered this question. Which is better, Y or Z? It's a matter of convenience. Okay. How would we go about measuring Z11 and Z21 in this case? Please try to answer this question. How will I measure Z11 and Z21? Previously, we short circuited the output. So why should we short circuit the output? I think I made a mistake in writing this. This is, I should have written I1 and I2. Okay. So these are I1 and I2. Okay. So one of the answers is that the output, the port 2 is short circuited. Why is that the case? How would I measure Z11 in this circuit? If I want to determine the value of Z11, what should I do? What should I apply to port 1? What should I apply to port 2? How should I measure it? So please try to answer this. How would I measure Z11 and Z21? So a couple of you were able to answer it correctly. Clearly, Z11 Z11 appears only in this term. So if I make this term 0, it would be most convenient. Okay. So what I will do is set I2 equal to 0, which means that port 2 is open circuited. Okay. So there are some who have responded saying that we have to short circuit the terminals. No, we have to set I2 equal to 0, which means that we have to open circuit port number 2. In that case, we will get only these terms Z11 I1 and Z21 I1 for V1 and V2. Okay. So open circuit port number 2, which sets I2 equal to 0, and measure the voltage across port 1. That will be Z11 V1, Z11 I1. Okay. So V1 by I1 with I2 equal to 0 is Z11. Okay. Similarly, V2 by I1 with I2 equal to 0 is Z21. Okay. How much voltage appears across port 2 with when a current I1 is applied to port 1, that is Z21. Okay. Similarly, we can easily see that Z12 is V1 by I2 with I1 equal to 0, that is port number 1 open circuited, and similarly Z22 is V2 by I2 with I1 being 0. Okay. So because we measure the Z parameters by open circuiting one port or the other port, that is to measure Z11 and Z21, we open circuit port 2. To measure Z22 and Z12, we open circuit port 1. These Z parameters are also known as open circuit parameters. Okay. Any questions about this definition of Z parameters and how do we measure it? We have to open circuit the other port, open circuit one of the ports and measure 2 Z parameters, and then open circuit the other port and measure 2 more Z parameters. Okay. Is this clear? Okay, there is a question. What do you mean by symmetry? I'm not clear about the context of this question. I mean, what circuit does it refer to or anything like that? Okay. So now let's quickly go through an exercise. It's probably best if we take the same circuit that we took last time. Okay. Previously, in the previous class, we calculated Y parameters of this network. Okay. So this time, let's calculate Z parameters of the same network. Okay. That will also let you easily appreciate the relationship between Y and Z parameters. Okay. So please calculate the Z parameters. Okay. First calculate Z11 and Z21, Z12 and Z22. Okay. So please calculate this and give me the values. First let's start with Z11, then go to Z21. So you can use the expressions I gave earlier. Z11 is when you set I2 equal to 0, V1 by I1. Z21 is when you set I2 equal to 0, V2 by I1 and so on. Okay. So what will be the value of Z11 here? I hope all of you are able to start solving this, because it's just a simple calculation of circuit with 3 resistors. Okay. Please be careful with the units. I mean, it says 1.66 ohms. I'm not sure how that came about. All our resistances are 2 kilo ohms, 2 kilo ohms, and 8 kilo ohms. Okay. Okay, I got one answer for Z11. What about Z12? What is Z12? Please calculate Z12 or Z21, whichever you find is easier, and similarly Z22. So the question is to calculate the Z parameters of this network. The resistor values are given, and I've also explained how to calculate Z11, Z21, Z12, Z22, etc. To calculate Z11 and Z21, you have to open circuit port 2, and to calculate Z12 and Z22, you have to open circuit port 1. Okay. So there is a question asking for more explanation, but please be more specific which part you want an explanation for. Did anyone calculate the value of Z21 or Z12? So as I mentioned earlier, to calculate Z11, you set I2 equal to 0 and take V1 by I1. And this is not some mysterious formula I came up with. If you look at this, V1 is Z11 I1 plus Z12 I2. If you set I2 equal to 0, this part goes away. That is, if you open circuit port 2, the second part goes away, and V1 will be Z11 I1. So V1 by I1 will be Z11. Okay, and V1 by I1 is nothing but the resistance looking into port 1. Okay, so V1 is here and I1 is flowing there. So V1 by I1 is the resistance flowing into port 1. Sorry, resistance seen in port 1. Okay, and similarly, if you set I2 equal to 0 here, V2 is Z21 I1. So if you apply I1, measure the value of V2, take the ratio, that will be Z21. That is, if you apply a current here, how much voltage develops in port 2? That will give you Z21. Okay. So let's do that for this case. First of all, to calculate Z11 and Z21, we have to open circuit port 2. Okay. So that means that basically you don't connect anything here, right? This is open circuited. And you apply V1. Okay. So now you apply, sorry, I made a mistake in this. You apply I1. And you measure the value of V1. Okay. So now as I said, V1 by I1 will be simply the resistance between these two terminals. I hope that part is clear to everybody. If you have two terminals and if you measure the voltage in this way and the current going into the plus terminal with the plus sign, then V by I is nothing but the resistance looking into those two terminals. Okay, by definition, that's the resistance. So here, what do we have? We have the resistance looking into here would be 2 kilo ohm in parallel with this whole thing, and this is open circuited, right? So we have 2 kilo ohm plus 8 kilo ohm, that is 10 kilo ohm, and 10 kilo ohm in parallel with 2 kilo ohms. Okay. So Z11 will be 2 kilo ohm parallel with 10 kilo ohm, which is basically 2 kilo ohm times 10 kilo ohm divided by 2 kilo ohm plus 10 kilo ohms, which is 20 by 12 kilo ohms, or you can also write this as 5 by 3 kilo ohms, which is basically 1.67 kilo ohms. Okay. So essentially you have to do circuit analysis with a single source I1 applied here. You have to find V1. So V1 by I1 will be the resistance looking between these two terminals. Okay. Also, if you apply I1 here, you have to find the value of V2, that is the voltage that appears between these two. Okay. To do that, first you calculate how much current flows here. Okay. If I1 is applied here, how much will be the value of I? That you can get from current division. Okay. So this I1 will produce some I, it will produce some current in here and some current in here. Okay. So the value of I will be, how much is I? Please try to answer this as a fraction of I1. I1 will be, I will be proportional to I1, but how much will it be? What will be the fraction? If you have I1 applied here, how much of it will flow through this 2 kilo ohm and 8 kilo ohm series combination?